Assalamu alaikum students. Today's our lecture is going to be about numerical of chapter work and energy. Let us find out about the first numerical which we are going to do. It says a 70-kilogram man runs up a long flight of stairs in 4 seconds. The vertical height of the stairs is 4.5 meters. Calculate his power and the answer should come 7.7 times power 2 watts. Now here is the basically stairs which he wants to climb, and the height of these stairs are approximately or given to us is 4.5 meters right over here. So we're talking about this man. He wants to run up these stairs of right over here, and at the top he reaches that in 4 seconds right over here. So here's our data. The mass of the man is 70 kilogram. The height is 4.5. The time in which he does this whole process is 4 seconds, and we have to find the power of this man. The formula which we have is work done over time. Instead of work done, we can say the potential attained by that man, which is equal to mgh, where m is the mass, g is the gravitational acceleration, which is 9.8, and h is the height of the stairs. So 70 is the mass, 9.8 is the value of g, and 4.5 is the height, divided by time in which he reached up the stairs. So the total amount of mgh was equal to 3087 divided by time, which is 4. So our answer basically comes to 771. So this is 1, 771. So 771, like over here, 0.75 can be run into approximately 7.71 into 10 to the power 2, which I've done over here. So this is the point which we want to discuss. The power will be equal to 7.7 into 10 to the power 2 watts, and that is our required answer as well. Moving on to the next question, which says a body of mass 2 kilogram is dropped from a rest position 5 meters above the ground. What is the velocity at the height of 3 meters above the ground? The velocity should come to approximately 6.3 meter per second. Now here's the body of mass 2 kilograms, and it is at the height of 5 meters. It is dropped, and at this position we have to find the velocity. Let's call that velocity vf. In the start we say the vi was 0 meter per second because it was at rest. So what is going to be the velocity of this mass of 2 kilograms at the height of, let's say, 3 meters? Let's call that height equal to h1. So the data which is given to us is the mass, which is 2 kilogram, the initial velocity and the start. So it is not meter per second square, it is just meter per second, which is the initial velocity. The height of the body is 5 meters. The height of the body before reaching the ground is 3 meters. The distance traveled by the body is h2. That means this much is h2, which is h minus h1, which is equal to 5 minus 3. So we can find it from there. 5 minus 3 will be equal to 2 meters. So this much height will be equal to 2 meters. Because we take that h2 and h1, when they add up, basically that is equal to the total height h. Let me clear this out. Now, the formula which we have is the potential which is loosed by the body in motion is gained through the energy in the form of kinetic energy. So that is why I've written the loss of kinetic, the gain of kinetic energy, sorry. The gain of kinetic energy is equal to half mv square is equal to the loss of potential energy, which is equal to mgh. From this, we can find out the value of V, taking all the other values on the other side, cancelling out these two m. When 2 is taken to the other side, taking under root on both sides, we get V is equal to 2gh. Putting in the value of g and h, what do we get? 2 into 9.8 into 2. Our answer will come approximately 6.26, and when we round it off, it is going to be 6.3 meters per second. And please, one more thing, you have to remove this one, and this is 2. not a square, otherwise it will become acceleration. So we are only talking about velocity. So VI is equal to 0 meter per second. Moving on to the next question, it says a man pulls a trolley through a distance of 50 meters by applying a force of 100 Newton, which makes an angle of 30 degrees with the horizontal. Calculate the work done by that man. So here's the man with a trolley, and he's basically pulling this trolley, making an angle of 30 degree with the horizontal, and the force applied over here is 100 Newton. Sorry. Now in this case, let's move the man. He's moving from this point to this point, and he says that about a distance of 50 meters was traveled. So here we have the data now. The solution says that means the data, the displacement is equal to 50 meters, the force is equal to 100 newtons, the angle which is over here is 30 degrees. We have the formula of work done is equal to Ft cos theta, putting the value of F equal to 100 Newton, putting the value of displacement which is equal to 50 meters, and theta is equal to 30 degrees. When we multiply 100 with 50, we get 5,000 cos 30. And when we basically multiply them, we get 4,330 joule. And that is our answer. Next question. It says a roller coaster car starts its journey from a vertical height of 40 meters on the first hill and reaches a vertical height of only 25 meters on the second hill. Where it slows to momentarily stop, it travels a total distance of 400 meters. Determine the thermal energy produced and estimate the average friction force on the car whose mass is 1000 kilograms. Now here's the condition. Here's the roller coaster and here's a roller coaster ride. Now, when it goes from 40 meters, which is we are calling the height H1, to another height, which is H2, which is of 25 meters, and it traveled a distance of 400 meters. Here it goes down, then takes a curve, and then goes up. Now, in this case, as you can see, the tires of this roller coaster basically was having a friction between the uh, tracks of the roller coaster. So in that case, we have to understand the uh, loss of energy in the case of friction as well. So solution says the thermal energy produced is equal to the loss in mechanical energy. That means the thermal energy is over here, which is represented by EHT, is equal to the loss of the mechanical energy, which you can say the loss of potential energy. The negative sign over here is representing the loss of energy in that case. So the loss of energy will be equal to minus U2. That means the energy at this position, height, minus the energy loss at this position, which is height H1. The potential energy at H2 and the potential energy at H1. When we put in the values in this above equation, what do we get? First of all, we find out the difference between these two heights, which is equal to 40 minus 25, which is equal to approximately 15 meters between difference between these two. What do we get? We get minus 1000 because that was the mass of the roller coaster right over here, into 9.8, which is the value of g, into the difference of height, which is 25 minus 40. So it will be negative. So this negative and this negative basically cancels out, or you can say negative multiply by negative, we get the value of, let's say over here. Yes, like this, negative multiplied by negative, we get a value of positive. So in this case, we have done the same thing and we got the value 1,47,000 joules, and the initial kinetic energy and final kinetic energy will be equal to 0. Work by friction is equal to the change in mechanical energy. That means the work done by the roller coaster. So in that case, when it went down the slope of this curve, so it basically interacted with the tracks of the roller coaster, and because of that reason, there was friction. So it is taken to be as negative, but the displacement was there. So Wn is equal to minus the friction force into displacement, or we can say the change in mechanical energy or the release of thermal energy in this case, we can say over here. When put in the values and find the values of friction forces, what do we get? we get the friction forces is equal to the thermal energy divided by the displacement, which was how much? 400 meters. So the energy basically lost by the potential and gained through the thermal energy, which was equal to 1,47,000, or we can say it as 100,000 47,000 divided by 400. It will have a value approximate equal to 367.5 newtons. So that much energy will be wasted in friction. Moving on to the next question, question number 5. He says a man whose weight is or mass is 70 kilogram walks up to a third floor of a building which is 12 meters above the ground in 20 seconds. Find his power in watts and horsepower. Now the power we will find in basically have a value of 411.6, and the watts value will be 0.55 horsepower. The mass of the man is 70 kilogram. The height of the building is 12 meters. The time taken is 20 seconds, and we have to find the values in watts as well as power. Now we have the formula: power is equal to work done over time taken, or the potential energy divided by time, or mgh divided by time. All have the same values. So the mass of the man is 70 kilogram. The uh, acceleration due to gravity is 9.8, and the height is 12 meters divided by time, which was given to us, is 20 seconds. So the power which we gain from this formula will get 411.5, which was the right answer. And when we convert the watts into horsepower, 1 horsepower is equal to 764 watts. So we divide the watts by 746. So we get 0.55 horsepower, and that is how we get the answer. Question number 6 says, to what height can a 400 watt engine can lift a 100-gram mass in 3 seconds? So here's the data. The power is 400 watts. The mass of the man is not 70, it is 100 kilogram. The height which is given to us is not to be given. And the time which is also not 20 seconds, it is basically 3 seconds. Now putting in this value, what do we get? The formula: power is equal to mgh. So we have to find the height in this case. So what is the height in this case? So h has to be found out. H is equal to the power into time divided by mg. So the power was given 400 watts. The time was given 3 seconds. The mass was basically 70 over here, and the value of 9.8 basically is the value of g. So our answer will come approximately equal to 0.122 meters. Moving on to the next question, it says a ball of mass 100 kilogram is thrown vertically upward with a speed of 25 meters per second. If no energy is lost, determine the height it would reach if the ball only rises to 25 meters. Calculate the work done against the air resistance. Also calculate the force of friction. Now we have to find 3 things, and there are 3 answers as well. He says a ball of 100 kilogram is thrown up with a speed of 25 meters. So here it goes up. Let me clear that out. So it basically reaches to what height we don't know. But as soon as air resistance is there, it reaches to a height of 25 meters. That's why we are representing it as h dash now. Now, in this case, the data which is given to us is a mass of ball is 100 grams, or we can say 0.1 kilogram. The speed of the ball is 25 meter per second. The height to which ball would have reached if there was no air resistance, that means h, we have to find that as well. If the height is given when the air resistance was there, it was 25 meters, then what will be the work done in the friction forces, and what will be the force of friction in that case? We have to find that as well. For that calculation, we can find, ignore the air resistance, and then the loss of kinetic energy is equal to the gain in potential energy. So if there was no air resistance, that means there was no loss in kinetic energy, and basically there was a gain in potential energy. So half mv square is equal to mgh, from which we can find out the value of h and v square as well. From there, we can say h will be equal to v square over 2g. 2g, which will then put the values of v square, which is 25 square divided by 2 into 9.8. the height which we have gotten or would have gotten when there was no air resistance is going to be 31.9 meters. So that is the height which we want, 31.9 meters when there was no air resistance. So in the next question part says that when there was air resistance, what height or what work was done by that force of friction, and what was that force of friction in that case? So h dash is equal to 25 meters. In case of air resistance, we have loss in kinetic energy and gain in potential energy plus the work done against the friction as well. Now the work done is equal to the loss in kinetic energy minus gain in potential energy. Just rearranging the above equation, we get W is equal to half m square minus mgh dash. Putting in the values, what do we get? W is equal to half m 0.1, which is m, into 25 square, which is the velocity. This is the velocity, minus 0.1, which is the mass. 9.8 is the value of g, into h dash. That means the height in that case. So when we put in the values, we will get 31.25 minus 24.5. So in that case, the work done in this whole process will be 6.7 joule. That means this much energy was basically lost due to the air resistance, due to which we didn't get our height which we were supposed to. So 6.7 joules were there in the case of friction work done. Now we have to find the friction in this case. We know that the work done is equal to F into D. So we have to find the frictional force. W is equal to F into H. That means how much height it basically attained, which is the H is the distance. So the frictional forces will be equal to work done divided by the height attained by that body, which is equal to 6.7 divided by 25, or we can write down as 0.26 newtons or 0.3 newton as well. And this is how we can solve question number 7 in numerical as well. Moving on towards numerical number 8, an object of mass 1000 grams falls from a height of 3 meters on the sand below. If it penetrates 4 centimeter into the sand, what opposing force it exerts on it by the sand, neglecting the air friction? Here we have the mass, and here's the sand over here. Now, as soon as we throw or basically fall this mass onto the sand, it falls a distance of 30 meters and goes into the sand. It penetrates into the sand just like this, and it penetrates up to 4 centimeters just like this. Now, in this case, it says the solution, the data which says mass is 1000 grams, or we can say 1 kilogram. The height it obtained is 3 meters. The distance to which object traveled in sand is basically the penetrating power, which is 4 centimeters, or we can say 0.04 meters in SI units. So we have to find the opposing force. So the solution says the loss of potential energy, which is over here, is the work done by that body on the sand so that it can penetrate into the sand 0.04 meters. Putting in the values, mgh is equal to fs, that means force into displacement, and we define the force of penetration is equal to mgh divided by s. M is 1 kilogram, 9.8 is the acceleration, into 30 meters is the distance, divided by 0.04 meters is the basically distance travel body into the sand, and the force of penetration is given by 7,350 newtons, and that is our answer as well. Moving on to the question number 10, a body of mass m drops from a bridge into a water of river. The bridge, I think this is question number 9 or 10. So the bridge is 10 meters height from the water surface. Find the speed of the body 5 meters above the water surface, and find the speed of the body before it strikes the water. Now, there are two conditions over here. Let's consider this as a bridge, and this is the ball which we want to consider, and the ball basically is 10 meters at the height h1 from the river. It falls down to 5 meters away from the river, and we have to find the velocity at this point. So let us take this look at the solution. In this case, mass is m. The height of the bridge is basically 10 meters of height, which is h1. The initial velocity is given to v is 0 meter per second. So the H2 is basically the height attained by that body before we take hit the water surface, which is equal to 5 meters. We have to calculate the final velocity at this position now. Final velocity at the surface of the water as well. We have to find two velocity in different cases. Now for this case, for the yellow case, this much height, the gain of the current energy is equal to the loss of potential energy. That means half mv f square minus half mv initial velocity square is equal to mgh1 minus mgh2. So putting in the values, because we know the initial velocity was equal to 0. So we put in the value 0, this whole thing becomes 0 initial velocity. So half mv square minus 0 is equal to mgh1 minus mgh2. Half mv f square is equal to mgh taken as common. H1 minus H2, taking square of both sides, or we can take the square root of both sides, because m and m cancels out, 2 is taken to the other side, it will be v square is equal to under root 2g into h1 minus h2, and vf is equal to under root 2 into 9.8, which is equal to 10 minus 5. We get under root 2 into 9.8 into 5, we get the final velocity equal to 9.9 meter per second. That means velocity at this point will be equal to 9.9 meters. So here we go. The velocity at this point will be equal to 9.9 meters per second. Now, if the body is about to reach at the surface of water, which is down below, right over here, we have to calculate the velocity at this position as well. Now, in this case, he says the initial velocity is basically, again is taken 0 because we are considering it from here. The final height basically is becoming 0 at that point, but the initial height was taken to be as 10 meter per second. So h1 will be 10, but h2 will be equal to 0. But the initial velocity will also be taken as 0, so we cancel out this one. So it will be half mv square minus half mv 0. This whole thing comes 0 is equal to mgh1. So half mv f square is equal to mgh1. So vf square is equal to 2gh1. Or we have to find the final velocity. Well, it was touching the surface of the water, so vf is equal to under root 2gh1. Vf is equal to under root 2 into 9.8 into 10, which is equal to 14 meter per second. That means the velocity of the ball at the surface of water was calculated out to be 14 meter per second, and this is how we can calculate the answer for question number 10 in this case. Moving on to question number 11, he says engine of JF Thunder fighter made by Pakistan and China develops a thrust of 300 Newton. What horsepower does it at a velocity of 600 meter per second? Now, in this case, we have a data which is given to us. Thrust of the engine is which is 300 Newton. The velocity which is given to us is 800 meter per second. The horsepower we have to find out. Now, in this case, we have a formula. P is equal to VF cos theta, because because it is moving along the same direction, the force and displacement. So that is why we are taking theta to be equal to 0. So the force is basically 300 newtons. The velocity is equal to 600 meter per second. Sorry, 800 meter per second, because this is given in the data. So over here we have to correct it. It is 600 meter per second. So putting in the values, what do we get? We get 6 multiplied by 3. It is going to be 1800000 into 1, which is equal to let's say 1800000 watts, or power is equal to let's say 18,000 watts. 1,800,000 watts. And this is how we get the answer. Moving on to the next question, he says we have to convert that into horsepower. So dividing that value by 746, because we know that 1 horsepower is equal to 746 watts. So we get the value of 2,412.9 horsepower. Moving on to the last question of this chapter, it says the mass of the moon is 1/80th of the mass of the earth and corresponding the radius of 1/4 of the earth. Calculate the escape velocity of the surface of the moon. Now, in this case, we are giving the solution. The escape velocity of the earth's surface given by the formula. Escape velocity is equal to v is equal to under root 2 gm divided by r. So the value of g we all know is 6.6 into 10 to the power minus 11, which is equal to Newton meter square divided by kilogram square. The value of mass of the earth, which is given to us, is 6 into 10 to the power 24 kilograms. And the radius of the earth is basically 6.4 into 10 to the power 6 meters. This much we know, but he says the mass of the moon is 1/80th time less as compared to the earth, and the radius of the moon is basically 1/4 of that of the earth as well. Now, in that case, we have to figure out the ratio between these two. So the moon basically is basically taken as V E dash. That means the change in the Earth's mass and the radius we are taking. That's why we are taking V E dash divided by V E, which is the escape velocity of the Earth. So we say that 2 gm dash divided by r dash and divided by under root 2 gm divided by r. So over here, when we put in the values, we get VE dash divided by VE is equal to under root MR, because both of these G's we carry out because they are the same. So RM dash divided by MR under root MR dash. So the radius and the mass was changed. So we say VE dash divided by VE is equal to under root RM divided by 80 divided by under root RM or MR divided by 4. Now, in this case, if we cancel out these values because they are constant, so we are only left with this value, which is equal to VE, which goes on to the other side, and we know the value of VE escape velocity, which is equal to 11.2 into, we can say, 10 to the power 2 meter per second. And let's see if the values come out to be, yes, it is 11.2 into 10 to the power 3 meter per second. It is kilometers. So it is 11.2 into 10 to the power 3 multiplied by 2 divided by 9.8. We're taking under root of 4, we get 2. We take the under root of 80, we get 8.9. When we multiply with 11.2, the answer comes out to be the velocity, escape velocity of the moon is calculated out to be 2.51 kilometer per second, and that is our answer. Another method of doing this is basically by substitution method. Now, the substitution method says that you have the value of the Earth's gravitation value, and the escape velocity is also there. So escape velocity is equal to under root gm divided by r. Now, in this case, we can say VE dash says that we are going to change in this one. So GM divided by 80, because that was the mass, divided by the radius, which was fourth sine. So if we separate all of these values, we get VE dash is equal to 1 over under root 80 divided by 1 over under root 4 into, and what was this whole thing? It was equal to VE. So in this case also we'll get the same value, which will be equal to VE dash is equal to 2 over 8.9 multiplied by whatever the velocity, escape velocity, which was 11.2 into 10 to the power 3. So our values will be VE dash, the velocity, escape velocity from the moon, it is going to be 2.51 into 10 to the power 3 meters per second, or we can say 2.5 kilometer per second. So both of these methods are correct. So you take it, you can take it by ratio, or you can basically substitute the values. Both of the values will be correct. I hope you enjoyed today's lecture. Inshallah, we'll meet again. Allah Hafiz.